Hi everyone, my name is Andrea de Quintana Dugarte, and this is my math project on exponentials and logarithms, specifically on combining and decomposing expressions with logarithms. So to start off, let's just define what combining and condensing logarithm is. So when you're giving a logarithm expression, you either want it to combine it or condense it. Combine it means to either put it all into one simple expression, or you can either expand it and have one simple expression and expand it to a lot of different ones that still mean the same thing. So for us to be able to either condense or expand a logarithm, we need to follow some certain rules that are called logarithm rules to be able to do so. So the first rule that we're going to be looking at is the product rule. The product rule deals with multiplication and addition. So when you're giving a log expression that is multiplied, such as log a times c, you can also put it as log a plus c. So when you have a multiplication sign, you can separate those to an addition sign. And you can also do it vice versa. If you're giving an addition sign, you can put it into a multiplication sign. So the next rule that we're going to be dealing with is the quotient rule. The quotient rule deals with negative signs and division signs. So when you're giving a fraction or a division sign within the logarithm, you can separate it with a negative sign. So instead of a positive sign with multiplication, now we're talking about division. So what division goes with negative and multiplication goes with positive. And it can go both ways as well as the product rule. If you're giving a negative sign, you can combine it with a division sign. The next rule is the power rule. The power rule deals with exponents and the basis of the logs. So if you're giving, for example, this one, log a to the c, you can bring the c down behind the log and make that as base. It can go both ways. So if you have the base of the log, you can then bring it up to the exponent if you want to condense the logarithm. So this one is a zero rule. It's rather simple. It's just stating that if you have a logarithm with the base that is logarithm of 1 that has a base that is greater than 1, then it will always equal 0. So this is the identity rule. So the logarithm of the number, if that is equal to the base of the logarithm, then it will always equal 1. So this is the log of exponent rule. So if you have a logarithm with an exponential in it, and the base of the exponential is the same base as a logarithm, then the exponent that it's inside the logarithm number will equal, like the whole logarithm will equal to the exponent. And the last rule would be the exponent of log rule. So if you raise the whole logarithm that you're trying to find by its base, then it will always equal the number of the logarithm that you're trying to find. So k equals k. So now let's look at different examples. So problem number 1, expand this logarithm. Expand meaning take the simple expression and separate it into many different expressions. So log base of 3 of x to the power of 2 times y to the power of 3 over c. So to expand this logarithm, you'll have to start with the quotient rule since it's division. So since it's division, it will be divided with a negative sign. So now it will be log base 3 x to the 2 y to the 3 minus log base 3 c. And then since x is being multiplied by y, then you would use the product rule to separate that. So log base 3 x to the 2 plus log base 3 y to the 3rd minus log base 3 to the c. And since they are exponents, then we can use the power rule to bring them down. So you would bring down the 2 and you would bring down the 3. So your final solution would be 2 log base 3x plus 3 log base 3y minus log base 3c. So now let's combine this logarithm in problem number 2. So we have 5 log x plus 13 logs x to the third plus 5 minus 1/2 log x plus 1. So since we're trying to combine it, we're bringing this multiple log expression and we're trying to put it into one simple expression. So first off, we're going to use the power rule. So we're going to put the bases of 5 and 13, and we're going to put that to the exponents. So now we're going to have log x to the 5 plus log x to the third plus 5, that to the 13th minus log x plus 1 to the 1/2. So after that, we can see that we have an addition sign, so we can use the product rule to turn that addition sign to a multiplication. So now we're going to have log x to the 5th times x to the third plus 5 to the 13th, and then minus log 1/2 is equal to square, so log square x plus 1. And lastly, since we have a negative sign, we can use the quotient rule to put that all in a division sign. So now our new expression is going to be log, and then to a division sign, x to the 5 times x to the third plus 5 all to the 13th over x plus 1 squared. So now problem number 3, we're going to expand it again, so taking the simple logarithm expression and turning it into multiple logarithm expressions. We have log 32 to the radical third over y to the third. So to solve this, we're going to first use both the product and the quotient rule, since we have multiplication and division. So first we're going to add an addition sign between the 32 and the radical to the third. So we're going to have log 32 plus log radical third, and then since it's division, we're going to put a negative sign, so it's going to be minus log y to the third. After that, log 32 is just like a number, so you can solve that, and when you plug it into your calculator, we get 1.5, and then you can also replace the radical third to the x to the 1/3, and then keep the minus log y to the third. And then after that, we're going to use the power rule, so we're going to bring down the 1/3, and we're going to bring down the 3 and the y, so our final expression is going to be 1.5 plus 1/3 log x minus 3 log y. So lastly, we have problem number 4, combine this logarithm. So we have 5 log base 3x plus 2 log base 3 4x minus log base 3 8x to the 5th. So to first combine this logarithm, we're going to start off with the exponents, so with the power rule. So we're going to bring up the 5 and the 2, so we're going to end up with log base 3x to the 5th plus log base 3 4x to the 2nd minus log base 3 8x to the 5th. The 5th was already there, so we didn't have to touch it. So after that, we are going to distribute the 2. So the 4x to the 2nd is going to end up being 16x squared. So after we distributed that, we can use the product rule since there is a addition sign. So that is going to end up being log base 3x to the 5th times 16x squared, and then minus log base 3 8x to the 5th. And we can actually multiply inside the parentheses, so that ends up being log base 3 16x to the 7th minus log base 3 8x to the 5th. And then since there is a negative sign, we can use the quotient rule to put that into division. So our final solution will be log base 3 16x to the 7th over 8x to the 5th. So that is the end of the video and presentation, and I hope you learned more about logarithms, and I hope that helped you review for the pre-calc honor section. Thank you.